Welcome to a lesson on factoring quadratic expressions using the graph of the related quadratic equation. If you struggle with factoring, this lesson is for you. This lesson will focus on factoring quadratic expressions in the form of ax squared plus bx plus c, where a is equal to 1. There will be a second lesson with a not equal to 1. Let's begin by looking at the notes below. If ax squared plus bx plus c is factorable, then it can be written in the form of a times the quantity x minus r sub 1 times the quantity x minus r sub 2, where r sub 1 and r sub 2 are real rational x-intercepts of the related quadratic function y equals ax squared plus bx plus c. This indicates we can write the factored form of a quadratic expression by graphing the related quadratic equation and identifying the real rational x-intercepts. To factor x squared minus 2x minus 35, we determine the x-intercepts of y equals x squared minus 2x minus 35. And I'll be using Desmos to graph the functions. The nice thing about Desmos is once we have a good view of the graph, we simply click on the x-intercepts, which is where the graph intersects the x-axis. Notice the given equation has two x-intercepts, one at x equals -5 and one at x equals +7. And therefore we can let r sub 1 equal -5 and r sub 2 equal +7. And therefore x squared minus 2x minus 35, or a is equal to 1, can be written in the form of 1 times the quantity x minus -5 times the quantity x minus +7. Simplifying, subtracting -5 is equivalent to adding +5. The factored form of x squared minus 2x minus 35 is x plus 5 times the quantity x minus 7. Recall traditionally, we determine the factors of -35 that add to -2, which are +5 and -7. Let's look at another example. To factor x squared minus 14x plus 24, we can analyze the graph of y equals x squared minus 14x plus 24 and determine the x-intercepts. Notice the graph intersects the x-axis at x equals +2 and x equals +12. Therefore, we can let r sub 1 equal +2 and r sub 2 equal +12. And again, because a equals +1, we can write the given expression as 1 times the quantity x minus +2 times the quantity x minus +12. The two factors of the given expression are x minus 2 and x minus 12. And again, traditionally, the factors of +24 that add to -14 are -2 and -12. For the next example, we want to factor x squared minus 36, which is actually a difference of squares. But to factor this using a graph, we graph y equals x squared minus 36. Notice there are two x-intercepts. We can let r sub 1 be equal to -6 and r sub 2 equal +6. The factored form of x squared minus 36, where the leading coefficient a is equal to 1, is 1 times the quantity x minus -6 times the quantity x minus +6. Simplifying, we have one factor of x plus 6 and one factor of x minus 6. Let's take a look at one more example that's a little bit different. To factor x squared plus 6x plus 9, we will graph y equals x squared plus 6x plus 9 and determine the x-intercepts. However, notice this graph only intersects the x-axis at one point, -3, 0, but because the graph touches the x-axis at x equals -3 and then bounces back, we count the x-intercept twice, and we say r sub 1 equals r sub 2, which equals -3. So again, when the graph does not cut through the x-axis, but touches the x-axis and then bounces back, we let r sub 1 and r sub 2 equal the value of the x-intercept. Again, a equals 1, and therefore we can write the expression as 1 times the quantity x minus -3, and then another factor of x minus -3. Simplifying, we have two factors of x plus 3, which you can write as the square of x plus 3. This indicates the given trinomial is a perfect square trinomial. I hope you found this helpful.